I realized my mic was turned off. So let's try to. I realized my mic was turned off again. So let's try to make sense of what we have done so far. So, uh, previously what we were doing is the doc size, the database. The doc was too small, so we got chunks, only two chunks, and we were not able to really test it because the query was past the cooking and the score of the two chunks were similar, 7 points, I mean 76, here 76. So that's why we increased the size of doc. So we have four chunks now. Dim size was always 384, we're not changing that. Top two matches score equals 0.7955. We have that, and actually it makes sense because look at this chunk. Um, we have more cooking details keep together for simple tomato sauce. We're trying to, and probably this sip is pasta cooking course. So yeah, see, we also have pasta there, so it's nice. So that's nice. And then we have score equal to 0.78. The next one, and this is overlapping with the first one, so that is very good. The overlap effect is actually taking place, and the third one again is this part. Probably there is cooking here, so it's just semantically doing that. So yeah, we're not actually doing anything, it's just the model that is doing. But yeah, so we understand how chunking works. But yeah, so that's pretty cool. Yeah. Okay, then next we can focus on. Right now we pretty, since we have four chunks, we you do you want me to update the debug to print? No. So we can add this as a result actually. Git status, git admin dot c. Okay, git commit. Main dot c was not. Oh, okay. Oh, we just changed the docs, right? So git dot add doc dot txt. Okay, and then git commit. Add doc dot txt. Increase the result. I mean, increase the size of doc txt to increase the number of chunks so that we get a better view of the results. Okay, and also status. Let's also add devlog.md. Sorry, get add devlog.md. We can just add comment here and devlog.md for sanity. And what else is there? Yeah, also add models. Git status, git commit git and models dog. That's remote. What do you mean, bro? Hung up unexpectedly. What does this mean? Oh, it's large file. Okay, that's why. Yeah, let's just ignore then. Can do this. Yeah. Okay. Get add get ignore do. Come on. How many comments do we have? Okay, cool. So I want to actually learn about the gt.c and how it does. Read down things clearly. So plan will first map GD.c to few logical sections: model loading, tokenization, transformation, math, pooling, normalization, public event. Then we'll walk one section at a time, explaining with GT load in the model file format with small code excepts and plain English explanations. Now how GD is organized, big picture. is basically a self-contained but inference engine specialized for GT small. Yeah, okay. Data model representation, stock GT CTX holds config, weights, vocab plus scratch buffers. Okay, data model representation. Okay, so especially a hash map and model loading. GT load reads the .gd model binary into those fields. Tokenization, basic tokenize, word piece tokenize. Tokenize produces token IDs, truncate into max seq length. GT load reads the GT model binary to those files. Okay, that's fine. Tokenization, basic tokenize, word piece tokenize. Tokenize produces token IDs, truncated to max seq length. Okay. Overpass, transformer forward, trans embeddings plus 12 transformer layers. Okay. Pooling plus normalize, mean pooling delta normalize produces the final 3 to 4 dim vector. Oh, okay. Public API, that's fine. See the model context clearly here. So this is the model context. Okay, config, vocab size, hidden size, num layers, num heads. The hell? Intermediate size, max seq length. Actually, let's not pollute this. So sorry, upload agent. Okay, let's understand the gd.c clearly. So you're saying a model will contain um vocab size, hidden size, num layers, heads, intermediate size, max sequence length, vocabulary, array of vocabulary words, hash for word, all the context, okay, embeddings, token embeddings, position embeddings, token type embeddings, okay, embed, and then weight, transformer layers, full or not used for embeddings but loaded, working memory for inference. Oh, okay, okay. Pool or not used for embeddings but loaded. Okay. Um, Model complex numbers like hidden size, number of layers, vocabulary, mapping between token strings and token IDs, all the weights, embedding tables plus transformer layer weights, temporary scratch buffers, turning text into token IDs, tokenization, transformer does not read characters directly. What is a transformer? We don't know. It reads token IDs, integers, basic tokenization. Works through the string, splits into pieces on the white space slash t slash n slash r. Punctuation. Oh, okay. The transform does not read characters directly. So this ctext is just the configuration and vocabulary mapping between token strings and token IDs, all the weights. Embedding tables plus transformer layer weights. Oh, okay. Temporary scratch buffer. So after you do that, after you do the ctx context, are you loading it? Are you loading it though? Yeah, so here you're loading model path. Check magic. What is magic? We don't know. Allocate context. Okay, you're allocating it again and putting 1 for the size of ctx and then read config. You're reading the config from the f, okay, and ctx, you're putting everything. How like how are you doing that? F read. Oh, okay, so I think you need to read the um this thing, GT. I think you need to read that. I think the format is somewhere here. Simple binary concatenation. Header is magic plus config. Vocab size, hidden dim, layers, etc. Okay, that's why. And vocabulary length prefix UTF-8 strings. Weights is raw float 32, arrays in fixed order. That's why we're kinda doing this. 1 second. Okay, again, I think you can hear me. Probably you can hear me, right? Okay, again, let's talk about this thing. So if you look at the uh, yeah, the model format here, yes, that I think basically this the conversion that they're doing. Python converts GT model from safe tensors to GT model binary format. So load vocab from vocab.txt. We don't know what vocab is though, like what are the parameters here? And then load config.json. We have, oh okay, model directory config.json. Do we have the model here? No, we have the model there only. No. Yeah, so think about HF and then you can just do, okay, this is a JSON format. Once you download the model, this is the thing that is downloaded. Type sentence transform, model transform normalize. I think it requires a little bit of knowledge about transformers, to be honest. This is the vocab.txt. Oh, what the hell? What is this? What is vocab.txt though? Don't know about it. PyTorch model.bin, vocab.txt. So open vino model.binary XML. Or you can open XML here. So I don't know about that. Tokenizer.json is also there. Also the config is there here. So architecture is the BERT model. Attention, props dropout prop 0.1, classifier dropout null, hidden act GLU, whatever I think, hidden dropout prop. So this probably is the configuration that the model was trained on. So hidden size is 384, initializer range is that, intermediate size is that, layer norm APS max position embeddings model type BERT, num attention heads and PID token ID, position embedding types and absolute torch D type. Okay, that makes sense. Special tokens map.json. So probably just reading all of this and doing that, right? Makes sense. So again, once you see the Python script, so you just load in the vocabulary here, probably reading the config somewhere. Yeah, load config here, json.load model directory, this thing, output path is this thing. Okay, fine. Vocab size is config and that thing, and printf model config. Okay, very nice. Load vocabulary and load save tensors path and print all tensors names for inspection. Write binary format. Probably need to understand what the BERT model is, like bidirectional embeddings. I don't know, forgot. But yeah, write tensor. Write tensor is basically taking get tensor. Okay, it's a tensor. And then writing the tensors word embeddings dot weight transformer layers, writing transformation layers. Again, we need to understand what all this is. Attention FFN, no idea. So model shape to that and write tensor and that. Sorry. And then output layer, probably output path, right? Where you basically path output path open, and then just write it. Just write it. Okay, is doing write binary format like this. Struct.pack. Oh, so probably just packing it into packing the bits properly. Vocabulary, embeddings, transformers, and then you're basically importing into C here. So all of this is that, I think so. That's cool though. Turning text into token IDs, tokenization. Okay, so the thing is, the transformer does not read characters directly, it is token IDs, integers only, so basic tokenization. Walk through the string, splits into pieces on white space. Punctuation set of ASCII punctuation ranges, lowercase is everything. Example conceptually. Output token is this. Interesting. Word piece tokenization, subword splitting, word piece tokenization for each basic token like hello. It tries to break it down into subword tokens that exist in the model vocabulary. Oh, okay. That's why it's called vocabulary. Okay, so each basic token is broken down into subword tokens that exist in model vocabulary. It searches for the longest piece that exists in the vocab. It searches for the longest piece that exists in the vocab. Okay. Alright, okay. If it's not the first piece, it prefixes with hashtag when searching. Example area playing might become play. Um, uh, It those exists. Oh, nice. If it can match the same version, emits you an unknown token ID and advances. Nice. And then add special token CLS and separation. CLS and SCP. If you don't know what that is. Function is tokenized CTX text num tokens maximum. It builds the final token ID list. First token is always CLS. Okay, then all the word piece IDs for your text. Okay, last token is SCP. It truncates to max sequence length, so it fits the model. At the end of the token, you have token IDs sequence length -1. Okay. Attention mask, which tokens are real. It many NLP models you pad sequences to a fixed length and need a mask to ignore padding. In many NLP models, you pad sequences to a fixed length and need a mask to ignore padding. Oh, okay. Okay, so for a single text embedding, it does not pad. So it creates for every token it produced. So every token is real. Oh, okay. Okay. So does the pad because yeah, okay. Embeddings layer, convert token IDs to vectors. Now we have token IDs, but transform these vectors. Transformer forward, it creates for each position S. Hidden states as token embedding, token ID, first position embedding, token type embedding 0. Encode this loop that fills CTX hidden states. Addition token embedding, what does this token mean? Position embedding, where is it in the sentence? Oh, okay. So position embedding as in token type embedding. So all of these three things. Token embedding, what does this token mean? Position as it in the sentence. Token type embedding used for sentence pairs, and but here always type 0. Then applies layer normalization to stabilize the values. Step 5, transform layers, repeat n times. The model has num layers. Each layer does 2 big substeps. Self attention. Each token looks at other tokens. Okay, from current vectors, compute 3 new sets of vectors. Each token position I compute how much it should pay attention to every position. Softmax those. scores into probabilities. So they sum to 1. Use this probabilities to take a weighted average of this thing, and then press back to hidden size, add additional connection, apply layer norm, key point addition. Mixes information across the sequence feed forward network, process each token independently. For every network token, linear up a bigger dimension. Intermediate size. What I don't know what all of this means. Scale nonlinearity, fast forward network, basic feed forward network, process each token independently. And residual, apply layer norm, is applied for per token. Reduce many token vectors into one text vector. After the list transformer layer, you still have one vector per token position. To get one binding for the whole text, uses mean pooling, normalize the final vector. What you get from GD embed. So nice. And you might want to zoom in. Next pick one, we'll go equally slow through it. Okay, so I got it. Got a high level overview, but I think this deserves just another stream to do it, agent. Just needs that. So actually let's just focus on our thing. Let's just focus on our implementation. What is the next step? I think version 0 is done probably. Next step, recommended version 1 storage. Right now your pipeline works in memory. Each chunk embeds core. The next step that moves you is to make ingest persistent chunks embedding right to a flat binary file. Okay. Okay, that query. Load that files. Embed queries can all stored embedding stop. Okay. This is the first real RAG loop. There big new dependencies. Too small decision before we write store v1. Alright. Should the store file be something like store bin and data? So we want bin exact on disk format. Do you want to match plan.md exactly? Okay, so that's the nice text length, text, float embedding. Nice. If you say yes, match and pick the store path, we'll implement first just the API contract, then store v1.c, one file at a time. But do we commit though? Git status. Oh, not this. Git status. Okay. Actually, like, what are we doing is just using that and just trying to make sense of whatever is there. So embed them model chunks query print query, just the query. If the query is that num chunks is greater than 0, num chunks print out. So let's just do printf here, printing out the first chunk embedding. Then probably you can do this. second. Can do that. Can do this. Should do this too. Okay. And query num chunks embed batch. Yeah, okay. Num chunks. Best index is that. Best code is good to malloc. And storing it as malloc size tkk into size of float. Kk is just k. Okay, so if kk is less than greater than number of chunks, kk is number of chunks. Yeah, okay. Best index is calc size t, and then you're just doing that. And it's not actually calling gt embed, right? Embed batch, you're doing it here. qm, okay, that's fine. That's fine, but it's fine. But the query is if query print query is that, okay, and that's fine. That is fine. Okay, that's fine though. Chunks is greater than dim is greater than 0. Embed batch failed for query. Kk is equal to k. If kk is greater than num chunks, I need best index, best score. And then we have best index is I is equal to -1. Best score is equal to -2. Just initializing that. For each chunk, is that right? Is that right though? For that, Candy doesn't run the smoke test, obviously. That's fine. Read the whole file into memory. It calls read end file, which opens the file, seeks to end, uses ftil to get byte length, allocates n+1 bytes, reads the bytes and null terminus. So now takes a single big C string containing the document, chunk the document character based. Chunk the document character based. It's called chunk text. And this returns chunk card point chunks, where each chunks phi is a heap allocated C string. Chunk size is 1000 characters per byte. Chunk the document, yeah, okay. We can use chunk is a heap allocated C string. Chunk size 1000 characters per bytes. Has a bytes. OLAP is 200 characters or bytes. Load the embedding model. Yeah, load the embedding model. Okay, fine. It calls embed load, that grabs the GD load and returns a CDX embed order the GD CDX. Embed all chunks in one batch, calls embed. So it embeds all of the chunks in one batch that returns a float embeds of length num chunks into dim floats where dim is equal to 384. Yeah, that makes sense. All of the embeddings layout is continuous. Chunk 0 is that, chunk 1 embedding is that, contiguous. Okay, print debug info, print small path, file path, number of chunks, embedding dim. Now first 5 floats of this, first 5 floats of embedding if chunk 1 exists. If provided query prints the query in k. If query is provided retrieve top k chunks, it does a simple retrieval loop, embeds the query as one string by calling embed batch. So query is also embeds the query as one string by calling, yeah, so 1 second, as one string called embed batch count is 1, so query is also there. So for each chunk embedding, you can use the dot product with the query embedding, because it embed L2 normalizes embedding, that product equals cosine similarity. Then it keeps the top k chunk in as a score and prints rank, score, chunk index, chunk text, free everything. I mean, yeah. So, oh, so best score, you're doing that, okay. Makes sense though. No chunks, and then basically freeing all of it. Embed batch, embedding the chunk, embedding the query here. Yeah, embedding the query here. I'm sorry, I'm used to Python also, so embed batch, embed free. Yeah, this is just that. This is just calculating index and score. Of the chunks. For now we're not using any hash map, but indexes just calculated, I think, by dims. Yeah, we're calculating by dims, that's all. Yeah, that's literally it. And doing the dot product here, yeah, which is just the dot product. Yeah, exactly. So cool. Top percentage D matches, then you can just do that. Yes, okay, free, and then free everything. Makes sense. First modify read.c to make it more readable. So be more readable. Add comments. Yeah, so make it more readable. What is this? Why exact 3 help functions? There's still a lot to be done in this project actually. We just are just doing the retrieval part now. So yeah, we've just done the retrieval part as of now. Make main more readable. Output formatting more readable too. Okay. So okay, now we can move to next step. We keeps happening. I don't know why it keeps happening. We will do the data. I think data is cool. We end up in and should be hardcore 384 in the file format or store them in the header. Should be hardcore 384 in the file format, simple v1, or store dim in the header, slightly more future proof. Oh, obviously we need to store dim in the header, store dim in header. Yeah, it's just writing that. So propose store v1 API for write path chunks, num chunks, embeddings, and replace query, proof of scan, query. Free helper, two quick checks. Do you want these functions to return 0 on success? Return use num for 0 on success and chunk index plus also the chunk text. That's the binary that we're doing, right? Then we'll just add store v1.h git commit and version 1 store, add binary format in disk for the doc.txt, add a header file for that for the public API. Not public API, it's just the API to be used in main. That's all. and helper functions that for writing, for reading, for querying. Free heads, yeah, also free. Sorry. Yeah, that's correct. So now we can just look at this store. See, okay, tiny binary IO helpers and write 32, read U32, write F32, F32 dot product, okay, public API, store v1 write. Basically, just get all of these things and just write it as opening the file, and then just write the U32. You write U32 is again just using F, right? That's obviously right, no pun intended. And query top K, the thing hits, and then you can just do this, and then yeah, insert into sorted hits, descending, shifting down, free hits again, free that thing. Okay, git add store event.c, git commit add implementation of store v1, useful helpers for IO. It's actually feet. Then you can that's why I may not see. I think we can do it later. It's 8:30, so we can do this later. But yeah, that was a very good session. Oh yeah, probably a lot to do actually if you think about our plan here. You can see our plan right here. Oh, we are just are on the verge of completing version 1. Right, and then we should move on to in-memory hash table. And then we will hook on the database actually, and then we'll hook on custom vector index. Then you can vector index implementation. So probably using some Redis or something, we can do that. So it's a lot. So we can just create a repo. Actually, I did not create a repo for myself for this. So yeah, we can create a repo. We can create a create labs, right? Minimal rank. So we can building minimum rank, choose visibility, it is public, okay, create repository. Then we can basically just do this and get set remote. What is the command, bro? Set get remote to this thing. Am I authorized to do it though? I've hit my usage limit. Wow. Oh, that's convenient. Oh, shut up, bro. I think it's here, right? Remote add origin. Yes, okay. Remote add. Oh, I'm sorry. Yeah, remote add. Okay, that's thank you, GitHub. GitHub is also doing some good things. So, get remote add origin. This thing. Then we can do this, right? Yeah, okay. And then git push, right? Git push set upstream origin main. Could not read from remote repository. Doesn't appear to be git repository. Sorry, okay. Origin from main, and then that's all. We are done for now, right? Yeah. So it's cool. So now also add a readme actually. Add a readme to this repo. Well, we need to actually do main. We need to wipe main to our version 1. So also I think devlog finished retrieval for version 1. Right, which includes public API for writing, public API to write the store to a binary file, among other things. Top K query site, also free. Should wire this API to main.c. Mark it as to do. Git add readme, git commit, readme, also git add -u, git commit, and update devlog version, update progress version 1. I think it's alright. Git log one line. Let's push. Okay, that's all. Okay, that's all actually. We'll think about this later, so I need to go continue this later again. So okay, that's all. Yeah, I mean, any closing notes? Closing notes for today is just we're glad that I'm glad that we have started this, and it's been a long running stream. I've realized I need much more time to understand what Transformers is and all that GT stuff. We're not actually doing the embeddings and inference for the model, so probably we should understand the inference first. Probably first should understand the model configuration, all that things that should take a lot of time. So yeah, I think for our use case, we're just using the embeddings that are already there from the public API that it is created, and yeah, so augmentation generation for the version 1 probably will not take much more time. So yeah, we'll complete that in the next quick stream we can do, and we can complete that. Okay, thank you so much for watching this. We'll see you again.